So good evening, everyone. A warm welcome to all of you for joining today's webinar. I am Priyadarshi, your host for the evening today. So as we start this, we know that India is now more than 6 million EVs, and we are now entering a phase where nearly 200 gigawatt hours of EV batteries will retire by 2030. And most of them will still have 70 to 80% of their usage capacity. So what do we do with these EV batteries? We can't throw them, right? But this opens a major opportunity for us for repurposing stationary storage and building a truly circular battery ecosystem. Today, Battery 360, an initiative that I lead, a multi-stakeholder platform dedicated to accelerating India's transition towards sustainable, circular, and indigenous battery landscape. We're pleased to bring you today's webinar, which is on unlocking the second life battery opportunity, policy and market roadmap for India. We specifically mention it's the e-waste is not a waste, but an opportunity. This webinar is also supported under the UNIP-led project, Electrifying Mobilities in Cities, investing in the transformation to electric mobility in India, executed under the leadership of Niti Aayog, with funding support from Global Environment Facility. The project works team focus on freight electrification, battery circularity, and promoting a just and equitable transition to electric mobility. The component 2 of this project focuses on building a circular battery ecosystem, with creating an ecosystem for second life batteries with assessment of market potential and developing policy advisory framework. I know this is a really long introduction that we had for this webinar, but we have an excellent panel of researchers, industry leaders, and academicians and policymakers who will help us understand how India can build a safe, trusted, and scalable second life batteries. Thank you for joining us, and let's dive right into it. I'll invite Chaitanya Karuri, Associate Director at WRI India, to set the context for this webinar. Over to you, Chaitanya.
Thanks, Priyadarshi. And thank you everyone for joining the webinar. I'm going to build a little bit on what Priyadarshi started off by tantalizingly telling us what is the potential global battery retirement potential in the next few years, right? So why second life batteries? If we start with this basic question, I mean, there are at least 3 imperatives we can name straight off the bat, right? The first is the carbon footprint imperative. Raw material mining and battery manufacturing account for the largest share of GHG emissions in the battery value chain. So if there is any way we can squeeze more juice out of an existing battery that's already been made, rather than creating brand new batteries, then we should take that as much as possible from an environmental sustainability perspective. From a resource efficiency perspective, we know that again, mining has not only environmental impacts, but also ecological impacts and social impacts. So if we can reduce and delay primary battery demand by actually increasing the share of second life batteries that can substitute for battery requirements, then again, that's a win. And even from an affordability perspective, we know that batteries are a key cost component in many of the systems that they comprise part of, be it battery energy storage systems, electric vehicles, etc. And if second life batteries, which are now reported to come in at 30 to 50% cheaper than first life batteries, can start making a dent in the market, even as the rate of first life batteries falls, second life batteries, which are following in their wake, logically always will be cheaper. So from an affordability perspective in supporting the clean energy transition, second life batteries seem to make sense, right? So this is the why of second life batteries and why we're focusing on this topic so strongly. If we're talking about feasibility, we know that globally, megawatt hour level applications are already in place, be it for grid connected or off-grid storage in places like the UK, US, and other parts of Europe. We also know that for India, about 200 gigawatt hours of cumulative BESS demand will be in place by 2030 or so. And we also know that 50 gigawatt hours of retired EV batteries are expected to be coming onto the market, which are viable for second life applications. So potentially, again, looking at some of these projections, which are just projections, but nevertheless, 25% of the battery energy storage demand could be served by second life batteries retiring from EVs. So this is a potential win that we really need to leverage. And in order to do that, I think some of the questions this webinar aims to answer or start answering is what is the viability of second life batteries over their life cycle? We know that, okay, lower battery costs are what are a key attractor of second life batteries, but we know that batteries actually account only for, say, 50% of the total cost of a battery energy storage system. And second life batteries also have potentially lower cycle life than a first life battery. So how does, with these different factors, where do we end up in the equation of viability is a question. What are the applications? Is it lower cycle frequency applications for which second life batteries are better suited? So what is the viability at an application level? And what is the data from the ground pilots telling us? I think trying to understand some of this. What are the technology trends that can impact second life batteries? There is a growing share of LFP batteries in terms of chemistry, which we know have less viable recycling potential, which may again be an impetus for second life batteries. But at the same time, we also know that there are improvements happening at the electrode level and in the battery chemistries, which may also increase the first life of batteries. That in turn can adversely impact the pipeline of available second life batteries for other applications and reduce the viability of any refurbishers that are relying on a steady pipeline of second life batteries. So how are these different changes in the technology trends going to impact the second life battery pipeline in India? And finally, while our policy framework currently makes passing references to second life batteries, we know that there is a lot more clarity needed on how to incentivize second life. We know that there is issues of market trust and certainty because there are not adequate standards and certification processes for second life batteries. And apart from that, what are the various policy measures that are needed to strengthen the role of second life batteries in the value chain? So today, we are hoping to engage with people that know some of these things, with some of our insights on these things in a fruitful discussion on this topic. And I welcome you all once again. Thank you so much for joining us. Back to you, PD.
Thank you, Chaitanya, for that information and a wonderful context setting from you for the webinar. Now I would invite Mr. Manoj Kumar, Project Specialist, United Nations Environment Program, UNEP, to give us the welcome remarks.
Thank you, Priyadashi. Hope I am audible.
Yes, you are.
Thank you. Good afternoon and good evening, distinguished colleagues, partners, and friends. It's a great pleasure to welcome you to today's webinar on unlocking the second life battery opportunity on the policy and market strategies for India. As we all know, India's electric mobility transformation is gathering remarkable pace. Worth repeating the fact with other colleagues have mentioned just now, we have 6 million electric vehicles already on the road by end of financial year 2025. India is demonstrating global leadership in the transition. This rapid progress is a testament to the vision of a greener India, aligned with countries' net zero and sustainable development goals. But again, as some of the other colleagues mentioned, by 2030, nearly 200 gigawatt hours of EV batteries are expected to retire. Coupled with the fact that out of this, 70 to 80% of this capacity could be ideal for second life applications, for renewable energy storage, to backup power and grid balancing, so on and so forth. This is where, as sees a pivotal moment, a chance to build a circular battery economy that minimizes waste, maximizes value, of course, and contributes directly to the climate action. The second life batteries can serve as a bridge between the mobility and power sectors, which includes strengthening the renewable integration, expanding access to clean energy, and supporting resilient infrastructure for communities. From our perspective, this opportunity is more than the technology option. It is about redefining how we value the resources, shifting from a very standard linear model of use and discard to a circular model of reuse and regeneration. This would also be very crucial in creating more green jobs, reducing environmental leaks across the entire cycle. As some of the earlier speakers mentioned, this UNEP initiative on electrifying mobility in cities, supported by Jeff, is getting implemented in India with the partnership of Niti Aayog and WRI being the technical partners. Through this project, we are working to advance this vision, what we just mentioned. The project focuses on electrification, battery circularity as one of the key component, and also on the just transition aspects. Colleagues, we all know that policy and technology alone are not enough for this transition. We need strong collaboration between different stakeholders, be it government, be it industry innovators, research institution, and other partners as well, to design the frameworks, mechanisms, standards that can safely and sustainably scale the second life battery applications. In this context, today's webinar offers an important platform for such a dialogue. The insights shared, I sincerely believe, can help shape the roadmap for the necessary diagnostics, grading, and certification and reconfiguration, which are very critical for this application. Finally, on behalf of UNEP, I would like to thank all partners and participants for joining this discussion. Together, we have the opportunity to turn the end-of-life batteries into lifelines for other opportunities and to make example out of this for innovation sustainability that can go hand in hand. Thank you, and I look forward to a productive exchange. Thank you so much.
Thank you, Mr. Manoj Kumar, for that welcome address, and thank you, the unit team, for supporting this webinar. Moving ahead, so we'd like to call upon the TERI team for give us the technical presentation one, which is evidence-based learning from second life battery development. If Kapil or Alekhya is here, we can start with the presentation.
Okay, just a sec. Screen visible?
Yes, it is. Over to you, Kapil.
Okay, thanks. Yeah. First of all, I have a very short presentation from the learnings from our work on second life batteries and what are the key insights that we have from our work. So this is a short overview of the contents of my presentation. It will not take much time here. Why second life? I'm sure most of the audience here knows, and it is an important opportunity for all of us to create a new value addition in the EV ecosystem. Now, coming to the key characteristics of the second life. Typically, we refer to the first life of the EV battery from a capacity of around 100 to around 80, and after the batteries reach around 80% of the capacity, they can be reused for until around 30 to 40% of the capacity. And this utilization is what we are referring as second life, so that later the batteries beyond the 30% capacity could be recycled. So globally, TERI had looked into the various case studies on this subject, what kind of applications are getting deployed from second life batteries and all of this. Here is a short summary of these application categories. So it goes all the way from utilization of second life batteries for backup power and using it at EV charging station to boost the to manage some of the peak load from EV charging stations, The use of batteries for providing utility services, grid services like peak, peak shaving and integration with a larger capacity of solar and wind to manage the intermittency. Further, these batteries can also be used as a replacement for diesel genset and in energy storage. There are other interesting applications also getting evaluated. These include deployment in lower capacity of vehicles. Maybe from a four-wheeler, the second-life batteries could be used in two-wheeler, and to power some of the equipment like forklift, drones, and certain small power machinery. Coming to the learnings from our fieldwork, we're thankful for our project partners, MG Motor and Loham, who, who have helped us to implement four pilots in last year at Nainital district of Uttarakhand. So basically, what we did was the second life batteries from four-wheeler were repacked into a units of around 5 kWh, and they have been deployed at four sites for community use cases. These usages are like uh, schools, community bakery, and farmers training center. With these interventions, users have a reduced dependency on the unreliable grid power over there, and some of the electricity expenses have got reduced. Since we are doing this as a pilot work, we wanted to cycle these batteries on a daily basis. So we implemented a customized control logic so that the batteries could be cycled independent of the grid availability. Coming to the key learnings from these deployments, as you can see here, coming to the performance of these batteries have performed nominally in the extreme weather conditions of Uttarakhand, where the ambient temperature varies from around -10 to 45 degrees. Further, we have some takeaways from these deployments where there's a room for improvement. One being the auxiliary consumption of the hybrid inverter. We observed from the current work that there's an auxiliary consumption of around 50 to 100 watts. We know that some of the smart inverters come with an advanced feature of low energy consumption or standby mode, wherein the auxiliary consumption could be limited to around 50 to 20 watts under no load condition. Probably integration of a smart inverter with these features would provide a better value add for second life battery. Further, the BMS and inverter communication is the key because the moment this communication fails, there's a every possibility that the inverter would treat it as a catastrophic event and the power would shut down. So there's a need for improvement in this BMS and inverter communication. Further, we see that using the operational data of these batteries, there's a need for advanced data-driven approaches to estimate the battery degradation. Coming to the opportunities and way forward, we see that going forward, there is a immense opportunity wherein the practical validation of second life batteries in a diverse set of applications, right from grid level utility applications to higher capacity of battery deployments, maybe in few hundred kilowatt hour uh, to the order of 10 megawatt hour of that scale would be required so that the customer or the user trust can be gained. And by carrying out these deployments and sharing the learnings from these deployments, we will be able to achieve a uniform platform wherein the standards, policies, and regulations could be directed so that as we adopt a higher electric vehicle and the contribution of the quantum of these second life batteries would reach maybe few gigawatt hour, we have the right mechanisms in place to make the best use of these second life batteries. These are some of the references. The third being a open source article that we published based on this work. Thank you.
Thank you, Kapil, for that explanations and some opportunities that we have in the second life of batteries. And good to see some learnings from the project revive that you have already done. And probably there are more opportunities or more incidences that we see that the second life of batteries are used and used as an opportunity, I would say, rather than just a waste of these EV batteries. Good to see all that. Next, I have in line another technical presentation I have from the Minimind team. Mr. Manish Rathi, the VP Operations, would be presenting the same, which is a technical roadmap for transforming a retired EV battery into a stationary storage solution. Would be great to see all these that they have done. Over to you, Manish.
Hi, first to check, am I audible to you?
Yes, you are. Yes.
Yeah. Hi, good evening, everyone. I'm Manish, and business operations at Minimind. We're located in Bangalore, so the lot of India and recycling and batteries. I think most of us have already spoken.
Manish, you are not clearly audible. You are
Okay,
audible,
just
but not very clear. Probably near the mic or something. Yeah.
how is it
Closer to the
better?
mic.
Hello.
You can try again. Yeah. Yes,
Yeah.
please.
So yes, thank you so much. So we all of us have spoken most about the applications of the second life batteries and how are these put into the market and is it upscaling and what is the size of the market. I'll spend next 3 to 4 minutes just to say how we as recyclers in the industry are when we dispose the batteries, the first end of life batteries, and then how we derive the cells of it and we rebuild the battery packs and how these are deployed in the market. As we see that always India currently imports all of the lithium-ion cells primarily from China or other Asian countries. And this becomes a critical nature to us that how we can safeguard the imports and the forex that are being handled. With this, there becomes an opportunity how alternate ways we can still be using and providing alternate energy through lithium-ion batteries in the market. So that brings how the first end-of-life batteries could still be enabling circular economy, not just through recycling mode, but also extending the life of the batteries. If we see from the center that the batteries, end-of-life batteries go into the mode and collection happens through various spokes across the country. And that is where the batteries are brought down to the facilities or collection points, and then these are being dismantled and good cells, what we call in the industry basically, that are being able to refurbish a battery pack or build a new battery from the reusable cells, which has health and a good capacity, can be used into second life applications. The cells then goes into recycling only, which cannot serve the purpose of the second life or are physically degraded. We see that the second life market primarily poses when the capacity. So what is the meaning of second life? It is basically anything that has a minimum capacity left out. So voltage, capacity, and the internal resistance becomes primary factors that enable the performance of batteries, especially in the second life, and are still able to function in the market. Also, previously in the talk also was mentioned that cost is a big challenge for most of the markets, which enable the alternate applications to second life. So repurposing, refurbishing, and remanufacturing. Repurposing and refurbishing has been very standard in industry, especially for the electronics market, as we at some point would have been used refurbished mobile phones or repurposed mobile phones. I'll skip the application part as it was covered in the previous slide presented. So coming to the main part, when the batteries come back from the field, these are being safely dismantled and they are not going for direct recycling. The batteries are enabled in a way that we know the state of the health, we measure the capacity and the IR and the voltage of the batteries at the battery pack level, further on the module levels, and when the batteries are tiered down to cell level so that new batteries could be picked up. So these, the batteries after dismantling are assessed on the health, voltage, and IR. Further down, these cells are regrouped. Regrouped, why they are regrouped? So that these could be repacked into a new battery module and further can built into packs that can be serving various applications based on what is the need of the power and the energy of those applications. In doing so, the industry adopts the same practice or the same manufacturing practice that a new or a fresh battery would see. The only differentiating factor that becomes is that the dismantling aspect, which is very critical, and it tends to poses hazards as well because we have to handle a live batteries, and therefore there are significant practices that one involves and in the factories or in the location where these batteries are dismantled so that they are safely dismantled. And these batteries range from as small as like a drone or a two-wheeler battery, going all the way up to a four-wheeler or a bus battery pack, which can weigh 800 to 1,000 kilograms. So all these batteries are handled in the premises and tiered down to cells. Further, when the batteries are being deployed in the market, the OEMs or the refurbishing companies ensure that these are safely put down with necessary BMS protection.
Manish, can I just
Yes.
check one thing? You're still on the how does it work slide, right?
Yes.
Okay, perfect.
Yes, and yes.
Sure,
So,
sure.
so yeah. Yeah. Uh, so in doing so, in the whole process, what we see when the batteries are built and deployed, there are certain challenges that comes in the industry, and this is where the key focus lies of our discussion. Is that what we have learned from the market so far? We have learned from the market that majority of the batteries which were built in the first life or the nascent stage in past 3 to 5 years were not looked to design for reuse, especially recycling is still okay. So design for reuse is very critical. When you dismantle battery, it should be such that the batteries or the cells are intact in nature and they don't get physically damaged, even though they have capacity. Physically damaged cell is as equivalent to a dead cell, even though if it's a capacity. So we always encourage and we always ask OEM who are into fresh batteries design and manufacturing to look out an intent for reusability of their battery packs. Second, that becomes a challenge in the market is that any refurbisher or a second life use battery pack designer or a manufacturer, for them, there lies a consistency of supplies of the cell manufacturer, same product that is manufactured or supplied by a cell manufacturer, maybe from China, South Korea. So the intent is always is what application or markets are we targeting. The continuity of the product is always a key challenge for a refurbishing company because the investments that they would put down to build a battery pack in market and provide necessary warranties so that replacements are also in and available. Third, we have figured out is there are compliances and regulatory practices not in place for the refurbishing market, especially when it comes to comparison with the fresh battery, where we have necessary certifications under ARAI or ICAT body. However, we do not have a defined set practice for the regulatory and the compliances. And this is a significant gap that can be bridged in so that this would further uptake the second life applications across the various domains. And finally, that the sincere tracking of how these batteries are being put on market safely, that we enable a producer responsibility for a second use, or basically someone who is remanufacturing from the first end of life. So the producer responsibility should pass on to a refurbisher, which definitely this is in discussion with the Pollution Control Board in various platforms and forums. But this also becomes critical to the industry as a whole, that second life battery market or second life grows instead of getting plateaued, or the risk itself diminishes the use case of second life. So that's all from my side.
Thank you, Manish, for this wonderful presentation. Good to see some take producer responsibility also on the second life manufacturer. That's something new for me. And in the interest of time, we would now like to move ahead to the panel discussion that we have today. And today, we are not just having the Indian panelists here, but we are also getting some global perspective on the second life market. I will invite our moderator for the session, Anubhav Mishra from WRI-India, to take it forward. Over to you, Anubhav.
Thank you, Priyadarshi. Before I move on to panel, can I just request all the panelists and the speakers before that, Manoj, Manish, Kapil, Chaitanya, to just for a second switch on the camera so that we can quickly take a screen grab. If we can just quickly do that, we'll move on to the panel discussion. So I request everybody to kindly switch on the cameras for just a second.
Chaitanya had to move out, but yeah, we can go ahead for now.
No issues. Okay, I'm just checking with the host of the session if that is done. If someone can just let me know quickly so that we can move on with the panel discussion.
And I'm not sure why my screen is getting so blue.
Yes, it's done.
Thank you, Sharma, for this. Okay, so let's quickly move on to the extremely about to be interesting panel discussion. Let me quickly welcome the panelists for the session. Let me start with Polash Das. Polash is a program management officer at UNEP, and he's joining us all the way from Nairobi, Kenya. So welcome, Polash, and great to have you in this session. Moving on, next we have Mr. Alexander Char. He's the Chief Operating Officer of Connected Energy. He's joining us from UK. A little about Connected Energy. Connected Energy has been a global leader in transforming electric vehicles into energy storage solutions. And they have utility scale deployments in UK and Europe. They have been pioneering second life solutions, helping businesses maximize their renewable energy, and of course, supporting grid electrification. Great to have you, Alexander. Welcome to the session. Next, we have Neha Jain. Neha leads EV and innovation ecosystem for JSW MG Motors. Welcome, Neha, to the panel discussion. Next, we have Darshan, co-founder, Noonam. Hi, Darshan. Noonam is based out of Bangalore, and Noonam also has been working on circular economy of lithium batteries. They are developing second life solutions for EV batteries, especially in the energy storage space. Welcome, Darshan. And finally, we have Professor Jayashree Biswas. She's an assistant professor at Department of Metallurgical Engineering and Material Science at IIT Bombay. And one of her primary focus areas of her work has been recycling and material extraction for lithium batteries. So great to have these esteemed panelists today for the session. Can I request the host to pin the screen so that we have the appropriate speaker on the screen? So to start off with the panel discussion, let me directly get into the heart of the entire second life story. And I would like to direct this question first at Darshan. Now, Darshan, one of the primary questions around second life batteries is the safety. Safety concerns and the lack of consumer trust remain key barriers to large-scale adoption of second life barriers, right? From your experience, let us know what are the most critical aspects of building consumer confidence, and not only amongst consumers, but also amongst investors, especially on the reliability and safety of second life batteries. Darshan.
So, I mean, safety, by and large, let us say how the industry accepted it as a transition from lead acid to lithium ion in general energy storage and as well as in the EVs, right? So it was all on adoption and how proof of trust was put out. I think in short, as an ecosystem, we will have to communicate the existing installations. For example, at Nunam, we probably have now got maybe around 150 installations across India, and one of our oldest installation is 3 years old, should have delivered about 18 or 19 megawatt hour of energy from a 50 kilowatt hour end of life pack coming out of Blue Smart vehicle, let's say. So now, moment you have a statistic which backs the performance, then it is much more trustworthy per se. But having said that, it is also now fundamentally down to your product engineering, how well you understand lithium ion batteries, how much of access you have in terms of the information on its first life performance, how transparent are you with your end customers, or essentially the distribution ecosystem. So bottom line, transparency, both from the supply and your customer ecosystem is extremely important, and that is again is going to build your trust. And then and as an ecosystem, we need to be extremely sure what we are doing, especially in terms of rather how not to build second life battery packs, right? So if you have somebody not doing the due diligence of quality check while rebuilding, then they're going to spoil the entire market. So some element of a strong process certifications required to have this ecosystem in a healthy mode. Then maybe a one bad apple will spoil it for everyone. So that's extremely important that we as a manufacturing ecosystem, or let's say to some extent torch bearers of cycling of batteries, we are an ecosystem. One must understand that making sure these repurposed batteries are safe is a collective responsibility, and it's a win-win or either a lose-lose for all, and not just for the regulator, let's say the national ecosystem of policy making, or the OEM. It's a win-win situation for all. So pawning off a battery which even if anybody feels that is not worthy of repurposing, should not happen. I mean, if they know that this is, let's say, minor accident, you rather just alert the buyer that this is an accident prone asset, whatever, either they drop the whole asset or they take the due consideration before even thinking of repurposing. So such basic references have to be put in place, and we must be transparent before giving it off to a repurposer to work on it blindly. And I don't have to stress, I think we've discussed enough on data in various sessions. So the data transparency with the OEM is crucial. Otherwise, we are just building a wall of let's say mistrust, and it is killing both the battery value and increasing safety risk. So OEM association is extremely crucial, and without which it's literally let's say we are hanging in the balance in terms of safety point of view.
Yeah. Thanks, Darshan. Great insights. I mean, the fact that you said safety is a collective responsibility, I'm sure it resonates with everybody across the ecosystem. And you did stress much on the importance of transparency in terms of relaying information, in terms of data sharing, and of course, one of the primary concerns being quality and how it needs to be ensured. Moving on, I would like to direct the next question to Polash. Polash, probably the second most important question after safety comes down to economics. Now with the prices of batteries, I can almost use the word crashing, right? There might be a rising competition between the new and the second life batteries. So, from whatever you're seeing from a global perspective, how do you think can the environmental and the circular economy benefits that a second life battery brings to the table, how can they be effectively integrated into this entire, economic calculations, which would be required to sustain the second life industry? So, what are your thoughts on that?
Thanks, Anubhav, and thank you, WRI, for having me. It's a very interesting but a very difficult question, right? It's hard to count, environment and circularity benefit into cost benefit analysis, right? But firstly, I would say, second use is delayed recycling, right? So we can quantify the avoided emissions and the raw material use, right? And so if we repurpose EV batteries, it's like cutting 30% of the emission from the entire life cycle of carbon footprint of the batteries. Like so monetize this gain, right? So we can have something like circularity, carbon credits. So that can be explored, right? So that's one. Second is from the policy side, like the EPR should reward reuse, right? So, for example, the battery waste management rule, right, that introduced EPR and recycle content, recycling content mandates. So it should also credit repurposing, right? So the National Energy Storage Framework, right, that we see, that offers almost 40% of VGF. It should also include second life, battery based storage, right? So these things will incentivize, right, and also offer targeted subsidies or tax benefits for projects that are utilizing second life, batteries for say, right? Another thing that I would like to include is to encourage battery leasing, warranty extensions, or maybe battery as a service, right? This should also these aspects should also internalize the second use of value, right? So when you're bidding for a project for battery storage, they should also include the downstream saving using the reused batteries, right? And piggyback on the existing renewable projects. So I think each of these means can when included will help in tapping the entire the value of the the second life use of battery, right? So these are the things that come to my mind when you are trying to utilize the environment and other benefits in the battery, second life battery value. Okay, thanks.
Yeah, Palash, thanks for sharing the thoughts. I mean, very important points laid down there. Of course, carbon credits, financial products such as VGF, and leasing, battery as a service, and of course, one of the most important instruments is the EPR. So, if time permits, we will come back to some of these important points here. Moving on, before I move on to the next question, just a quick information for all the people, for all the attendees here. There will be a Q&A session at the end of this, if of course time permits. So there's a separate Q&A session at the bottom of your Zoom tab. So do type in your questions, and after the panel discussion, we will be taking up as per whatever time permits us. So that was a quick information for the attendees. Moving on. So when Kapil from Terry was sharing, details about Project Relive, he did mention that there is a lot of requirement of actual operational data. And on this point, I would like to bring in Alex from Connected Energy. Alex, Connected Energy has deployed about 10 megawatt hours of second life battery systems, right, across UK and US. And you have that advantage of studying that data, right? So can you just let us know, based on your insights from these, from the data of actually deployed second life batteries, how have these batteries performed in terms of reliability, in terms of degradation trends, and most importantly, in terms of safety track records? Can you share some of the insights?
Yes, of course. Thanks, Anubhav, for the question. And first of all, I would like to really thank WRI for the invitation for that webinar. I think it's a great opportunity for us to be part of the conversation. So we really welcome that. So thank you very much again for the opportunity. So that's a great question. And so as you said, we have about 10 megawatt hours of capacity, which is deployed. So not yet in the US. So we're only in Europe at the moment. And actually, fun fact about us, we were funded in 2010. So if you put this in the perspective of where the EV industry was, the Nissan Leaf was actually released on that year. And, 2010 is 2 years before the Tesla Model S was even launched, right? So, people are saying Elon Musk was visionary to bet on EV, and rightly so. Our funder went even a step further to say, well, not only EVs are going to be massive, but then what do we do with all those batteries? So as you can imagine, the conversation back then were a bit difficult, right? Because when we were discussing with vehicle manufacturers to say, well, we can do all of that and we can monetize all those batteries, they were like, well, great, let's have a follow-up in 10 years. So obviously we're now here in 2015, we have batteries, we have deployed all those megawatt hours of capacity. And I think so safety is really embedded in our approach. And here it really starts from day one. And what I mean by that is how you're going to design your system. So here there's two fundamental things which are really embedded into our ways of working. The first one is that we work at the pack level. So obviously you're all very familiar with, the architecture of an electric vehicle battery pack. You would have the packs, you have the modules within it, and then you have the cells. And which means that you could have three different strategies when you approach, the reuse, right? You can either work at the pack level, at the module level, or at the cells level. And there are some benefits and drawbacks for each of those approaches. So it's really going to depend on your use case. So our use case is grid scale. And so for that, we thought, well, actually, if we work at the pack level, if you think about it, not only you have capacity within that pack, but you also have a lot of technologies that are embedded within that pack that would have been developed by the vehicle manufacturers, right? So then within that pack, you have the BMS, you have the thermal runner management system, you have a lot of safety features which are developed and certified for the automotive industry level of safety, right? So working at the pack level from day one allows us to actually leverage all of those safety features and all of that certification and testing that would have been done by the vehicle manufacturers. So, we start directly from, let's say, a base unit, if you want, which is inherently safe because it's validated for automotive standards. Then the second point is actually we are working together with the vehicle manufacturers. So it's really a partnership. So when we design the system, we do 95% of the work, but they are really part of the development and they are providing that technical support. And this is really important because one, it allows us to optimize the performance of the system, to really maximize the value that we can get from those batteries, while maximizing the safety of that system. Obviously, they know their packs much better than we do, so they will know what are the right operational constraints in which we want the system to be using those batteries, right? So it's that conversation and collaboration with them from day one, which allows us to create those conditions. So, those 2 points from the start, before we even start to design a system, allows us to inherently have safety embedded into the system when we deploy it onto the site. As you said, now we have 10 megawatt hours of capacity. So our first proof of concept was delivered back in 2013, and our first commercial project were started to be deployed from 2017 onwards. And so that's a 20-foot container with 24 battery packs from the Renault Kangoo. So the Renault Kangoo is a small delivery vehicle, which is used by the post office in France. And what we've seen actually is that the same way the whole industry is now realizing that actually the batteries are performing a lot better than anticipated in the vehicle. When we started that conversation with Renault, that was part of that design with us, we were anticipating, you know, a certain amount of degradation per year, and actually the reality is a lot better than what everyone, you know, anticipated. So we see the same kind of behavior that the vehicle industry is actually realizing, which, you know, is a positive story for, you know, for everyone. So from that perspective, you know, it's been really a positive discovery. So we have, you know, I think around 800 packs that are deployed in all of our systems, and we didn't have any problem with any of those packs. You know, they're still running. We haven't done our first battery swap yet. You know, that's going to happen in the next couple of years, which means that, you know, touch wood, everything is really going well so far. In terms, so that's really important, and you know, it's all part of that ways of working together with the vehicle manufacturers and building safety inherently from the start. Then a second point, the last one that I want to touch base on is indeed data. So, you know, I think Darshan, you mentioned about the value of data, and I think we're in a probably unique position to have all of those systems, you know, deployed from, you know, almost a decade now, which allows us to have a huge amount of data on how those batteries behave in second life. So, you know, at a very low state of health, which is the kind of data that even the vehicle manufacturer sometimes is not performing that data, right? So we have a unique database that is available to us, which is very powerful, because then when we are having conversation with customers, with, you know, financiers and insurance, then we can really use that data and say, well, you know, that's real life data. We're not the one saying, that's the evidence from all of those years of experience and from all of our systems that we have in operations from all those years. So, you know, all those aspects, if you put all of those together, then it really allows us to build safety inherently from the system, working together with the vehicle manufacturers, and have a proposition for the end customer that, you know, is addressing the concerns that they may have on safety, reliability, and all those aspects.
Thanks, Alex, for sharing all of that. I mean, it gives a huge boost to the confidence amongst you know, everybody, knowing that the second life batteries have actually exceeded expectations and are performing quite well. And it's good to know that. I mean, and you've been deployed since 2017, right? So
yeah.
I think it's a great encouragement, and I'm sure the data that's being generated would even help the industry even more in building that confidence and trust, amongst others. Moving on, I mean, you know, a lot of speakers beforehand have touched upon the importance of EV OEMs, right? If we move on to, and even from a supply chain perspective, obviously one of the most important sources for second life batteries is from the automotive sector, the EV batteries. And here I would like to bring in Neha, JSW MG Motors. Neha, we did come to know when Kapil shared how JSW MG Motors has been working on this project Relive, right? So I would like to know from your perspective as an EV OEM, what more steps are you taking, or what more steps should EV OEMs take to support this battery reuse and repurposing industry, right? What are your thoughts on this?
So thank you, Abhinav, and thank you so much to the WRI team for having me on this discussion. Extremely important topic, and you know, I'm really glad to see also hear Alex remark on the success of this project. So with MG, actually, when we started our journey on the electric vehicles in India, this was a project, or I would say an initiative, that we took up upon ourselves also before even the launch of the first car in the market. You know, because the thought was very clear that while we are launching the product, but we have to also ensure that batteries you know, reach their sustainable disposal, and so that included recycling and repurposing as well. Although 7 years back, I would say 6 years, when we launched now the vehicle, so the ecosystem was not that big, and you know, there were very few players in the market. But this is how our journey started, and we started engaging with a lot of players in the field, which were recycling, and you know, few players were also repurposing some of the batteries. And so we started engaging with them on pilots. So you know, the thought is very clear: if the battery has the life left after its first use in the automotive, basically, then before recycling it and recovering the materials, is it possible to extend that life? And there, the usage as a secondary storage, as an energy storage presents a very good use case there. So it has, I think, multiple benefits in that regard. Number one, as earlier also was discussed, this helps to extend the life of the battery in alternate uses. Secondly, it also is might not be commercially viable, as Pulash also mentioned, but it brings out a lot of environmentally positive outcomes, because rather than going for natural resources and going for this, it gives you a potential of extending those life and using that energy which is left in the battery. And then after maybe all use cases, when it is not useful for any of the applications, then we can go for recycling. And we all know that after recycling also we can recover the materials in the very good grade, which helps to build them as a source of raw material again for cell manufacturing. So this is how the entire loop get closed. So with this vision, actually, we started this journey, and I am glad to share that we have done 4 different kind of pilots. While repurposing this battery, which include an off-grid charging station, a BESS which is deployed at multiple sites, which Kapil mentioned, under Project Revive. We also did one use case for industrial application, where a 36 kilowatt pack was also utilized for an industrial application. And we are now on working on a lot of different kind of specifications as well, which can be deployed under multiple, I would say, locations and sites. So learning from this project has been really great, because we are still in a niche stage. And I would say, if you see Indian market also, lot of vehicles which are there on the roads are still in their first life cycle of an automotive use. So but yes, because this entire space is very niche, I would say. So here there's a lot of right now room for learning. This is an opportunity area for startups and also for tech partners to experiment, pilot, collaborate with each other. And like Darshan also rightly said, that this is an ecosystem approach, which is going to make this space more commercially viable and scalable, in a long run. So this is what Project Revive is all about. And we are working with recycling partners, repurposing partners, and also knowledge partners like Terry, to have these use cases deployed in the market and have the learnings in this journey. And so overall, yes, this is what we are looking at. And with more and more vehicles now, I'm also glad to share that we are seeing a good traction of electric vehicle adoption in India. We have already crossed 5% mark this year in the 4-wheeler segment, and which is again positive. And next year also, if this journey continues, we will have a lot of use cases where these batteries can be deployed and help to build the sustainable, I would say, value chain for from the manufacturing to the end of life of these batteries.
Thanks, Neha, for sharing those great insights. I mean, it again is really encouraging to know that even before getting onto the EV journey, a company like MG Motors integrated the second life and recycling into its overall strategy. And what it did is through the pilots, because the pilots became a part of all of them, it also helps to generate more operational and real world data, right?
Right.
Yeah. So I think it's a great step and a great work that JSWMG Motors is doing. Moving on, from a second life perspective, I mean, it is also important that the batteries are taken off from the first life when they still have sufficient, juice left in them. On this, I would like to bring in Professor Jayashree. Now, but as with every charge discharge cycle, we believe that it also alters the battery's internal chemistry and performance characteristics. Now, from a technical standpoint, what are those key parameters that you think should be evaluated to determine whether a retired EV battery is suitable for reuse, or it is fit for recycling? What are those technical parameters, and how can these diagnostic insights help ensure better safety and reliability for second life users? So, Professor Jashi.
So, hi. So, first of all, thanks Anubhav, and thanks WRIs for inviting me. I'm more of a recycling and a metallurgy person who is like who love to like kind of take out metals out of things. So, but the thing is, so when you have these batteries, so one terminology probably we are missing. So that is repairing. So is there any scope of repairing these batteries? So instead of just sending, like before you send these batteries for recycling, uh, and it kind of close to reaches to this 30% capacity. So is there any chemistry readjustment possible to actually revive the battery's capacity? So if that there is like there are some work now ongoing on the direct recycling, although partly it is for that you need to dismantle. So maybe for that we need to think about starting from the designing point of view. So is there any easy way to readjust the chemistry and make it like more to enhance the capacity, let's say, like to make it more simple way. So if that can be, so basically from the charging discharging point of view, it's lithium is the one which is going. So if there is a way, easy way, the lithium can be like, let's say, refilled, to make it simple way. So then I guess the capacity can be enhanced again, and the battery's life can be brought back as it is, like although may not be the 100% capacity, like you at the end for that you need to have like pure chemistry to start up with, as because their particle that also degrades. So there are coatings, all sort of things are there. So not only the just the lithium ion is gone, it also like morphology wise also it degrades. So you need to have at the end recycling. You cannot avoid that. But maybe you can extend a bit further, or you can make it kind of elongate the life of the batteries a bit more. But more of it, you have to be very careful about the safety thing. So as because there have been several incidents, like recently also there have been some incidents, so which is kind of people are still being skeptical to get into this EV, and then comes second life. So as Alex was also mentioning, they have already generated some significant amount of data, or such kind of data if we have already. So how about building such kind of like predictive models and giving some prediction that okay, so this is based on the history, it can like sustain, and in that predictive model couple of factors could be like, let's say, there one of the factors could be like some chemistry related information, some of their like kind of you are mentioning the cell, individual cell performance. So some of the like quickly measurable parameters, can you make a like a correlation out of it, and can you try to predict that? So that which can be made available for the, like some prediction can be made available for the battery when you are selling it, like the second life batteries when you are selling it. So based on like the previously like history, like which you have already. So these are the things I think can be done. And after that, if everything's nothing is going happening with the batteries, then anyway, and then you have to do recycling. But yeah, I guess repairing is one of the terminology which needs to bring into picture, apart from this reuse and recycling in between. That's what I believe. Yeah.
Thank you, Professor. I mean, one of the most important things that has come out is you're talking about reviving even after 30%. So are we talking about a third life of battery here? So
Maybe something like that. Maybe something like that.
So great perspective there. And you did talk a lot about database prediction models. So, and we've been hearing about this importance of data a lot. And I guess there are conversations happening around battery passport or battery Aadhaar, we're calling. Let's see if that serves any purpose in all of these conversations. Quickly moving on. Now, we did talk about, while building the contest, we did talk about a lot of gigawatt numbers. This many are going to be deployed, this many are going to retire, and this many gigawatt of batteries are going to reach their end of life, right? So my next question would be for Darshan. Now, Darshan, with the first generation of EVs now maturing, we are expecting a huge wave of battery retirements to happen. My question to you is, as an Indian ecosystem, are we ready to handle that much of volume in terms of technical capacity, in terms of skilled manpower, in terms of equipment availability, and also from a regulation perspective? If you can, my request, because we were a bit late in starting, my request to panelists would be to keep the answers short if possible, so that we can have a couple of follow-up questions to other panelists as well. That's a request. Yeah, Darshan, your thoughts on that, on handling the volume. Are we ready?
I think this prima facie answer is no.
No.
We are not ready. And probably we are not even there in terms of readiness. So if you give me a scale of 1 to 10, I don't know if maybe we are still in 1 or 2. But there is a larger question looming around, right? It's the unit economics and and the world changing dynamics on the prices of the new cells, etc. So apart from the challenges we spoke about today, the layer of the financial viability still, let's say, marks the cloud over the scaling of these solutions. However, again, my take would be more from a personal point of view, that there is, in that large pool, there are still going to be a decent pool of batteries, which maybe 10 nunams can still use it very, very effectively in that gigawatt hour count. So from a individual business point of view, there should be material. However, as a philosophical question, yes, new battery prices and the sizes. I think more importantly, the sizes at which these cells are coming out, that also impacts the unit economics per se. But I still believe that there is a opportunity, subject to the close collaboration between OEM and the repurposer. The case still does make sense, because anyhow the price of battery cell is relative to the price of lithium, I mean repurposed battery pack, right? The price at which you get, it's the fixed costs and the other processing costs which need to be put in control, and that is going to happen with OEMs support. I mean, I would rather boldly say unconditional support from the OEM. That's the only way this could work. And see, the downside, if people just forget repurposing, the downside is we have, in the hindsight, lost a lot of potential opportunity, which we probably would pay as a nation or a collective society 10, 15 years later. So whomsoever is the stakeholder in the entire value chain, whether it's the government or the OEM, has to take that position or a responsibility right now, to make sure that at least a fair amount of gigawatt hours which we are projecting in 2030 gets used, and it would truly be an energy storage superpower by then.
Thoughts, Darshan. So, I mean, the takeaway was your first word, probably no. So it only highlights the importance of the fact that a lot needs to be done. And probably what we are continuously hearing throughout this panel discussion is that it needs to be an entire ecosystem collaboration, probably, that can build this entire second life industry. Now, because we're seeing so much of challenges, my next question, I would like to come back to Alex here. Alex, if as an industry itself we are seeing so many challenges right now in terms of assurance of safety, in terms of economics, now because you have deployed certain projects, I wanted to know from you, how is the financing world looking at projects that have second life batteries, right? The financing and the insurance sector looking at covering projects or underwriting projects that have these second life batteries deployed. So what's your experience been on this?
Yeah, thank you. That's I suppose that's the $1 million question that everyone is trying to answer.
Yeah.
And it is, as you can imagine, obviously it is a challenge. And what was true 5 years ago is obviously different today because of various conditions. Everyone is mentioning about the price, the very low price of best systems that are coming out of China.
Yeah.
So it's a moving conversation, which is very challenging. I think predominantly due to probably two different gaps or three different gaps that as a collective industry we need to tackle. The first one is obviously it's a new technology, and as with everything which is new, the start is always going to be a bit messy and chaotic, and so there's a bit of an education piece that needs to happen with all the stakeholders and to work with them to show them how the technology work, to make them comfortable in the performance of the system, in the reliability, in the safety, and all those kind of aspects. And that's fundamental to any new technology. It's not specific to us, it's specific to any new technology. The second challenge is on the economics, and I think I would like to echo what Porash mentioned, is the opportunity, and I think some of the numbers that were mentioned also at the start, I think, was it 200 gigawatt hours of potential second life capacity by 2030? If you put this in the context of, what the Indian grid actually requires to electrify, that's too big of an opportunity, for us as a society. What is true in India is also true in Europe and in the US. It is too big an opportunity for us as a society not to leverage that. And I think here, this is where, Polash, you were mentioning about, carbon credits, incentives, tax credit, all those kind of regulations and policies needs to be implemented to really incentivize the end customer to do the right choice. I mean, obviously today there's not enough second life batteries to cover the whole best market. So, if there is enough batteries, then great, let's use that. If there isn't, you don't want to penalize someone to install the best, because that's still the right thing to do to decarbonize the grid, right? But you need to have all those incentives to say, well, because of those sustainability benefits, if you have the opportunity to do the right choice, then you should be incentivized for that. And then the last challenge is around regulations and standards. And I think here the challenge is, and to be fair, the best industry is also new. So, the best industry is new. So, second life best is even newer than the best industry. And the challenge that we're facing is that, when you go and discuss with the well-renowned compliance organization of the world, and you ask them, how do I certify a best? They will give you a checklist, you do X, Y, Z, blah, 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 job done. And if you say, well, I want to, but now it's a second life system, well, no one really has an answer for that, right? And so it really creates that problem that then you're kind of left guessing. So ideally, where we want to be is, to have a recognized standards, coming from the IEC, from the UN, from UL, or, whichever the organization, which is globally recognized, that says that if you are delivering a second life system and you are having X, Y, Z assumptions, then if you do A, B, C, means that you are achieving the same level of safety as a first life system. And then we would be able, as an industry as a whole, to use that and then go to the financing institutions, the insurance, and say, well, here's the certificate and the auditing process from the likes of DNV, Intertech. We are following that global standards, which is recognized by experts in the world. Job done, essentially, right? So, and this is what we are missing as an industry, and is, I suppose, really creating that challenge that, well, we are saying we're safe, but then how do you prove that? Obviously, we have data, we're doing a lot of testing and everything, but that gap of not having a well-recognized standard and regulations that address that is something which creates a lot of difficulties, and is something which I think as an industry we need to tackle as a whole.
Yeah, thanks for sharing those. Quickly moving on, I actually had a lot of other follow-up questions for Neha on EPR and Professor as well. But for my final question, in interest of time, I would like to go back to Polash, because everybody seems to be resonating with what Polash said on the importance of things like on instruments like carbon credits and all. So Pulash, from a global perspective, from UNEP's global experience, are you seeing certain steps being taken, best practices, policy movements happening around second life batteries, and are there lessons to be learned for India from these things?
Sure, thanks, Anubhav. I think since we are starting and we are at a nascent state, it's good to, good to have experience from what others are doing, right? So that's exactly what we are trying at UNEP. So in UNEP, we are executing battery-related projects in 36 countries, right? Right from in different regions like Latin America, Africa, Southeast Asia, on various different things like Second Life, Circularity, regulations, demonstration project. And we would like to bring all those regulatory and demonstration experience to India, right? So that we can help the country in building up a robust thing. Second is on giving technical guidance on second life batteries, right? Through the global partnership, we have a global partnership on battery circularity. And so through that, we have access to the various different methodology for battery health diagnostics, safety protocols. We are also creating some decision trees between reuse and recycling. So all these things are being experimented globally, and we are trying to bring those here so that we can help at least in standardizing the second life battery qualification process at least, right? The third thing would be on capacity building, right? Targeted training, South-South cooperation, exchange of best practices among the regulators, recyclers. So we are better equipped, right? And lastly, I would say giving some global visibility, right? Since we have the convening power, and UNEP can help position India, the India story at a global stage. So these are the few things which we think we will be contributing to, and and since we and WRI have partnered in one of the biggest project in India under Jeff, and these are the things that we'll be bringing in the next 3-4 years.
Thanks, Pulash, for sharing that. It's very encouraging to know that UNEP is doing this around 36 countries, and I'm sure the learnings would be there for everybody to learn from. I mean, the takeaways would be there for everybody to learn from. So thanks everybody. I mean, I did have a couple of questions, but in the interest of time, I'll quickly move on to the Q&A section, since we have a couple of questions here by some of the attendees. Let me take the first question. How does the IRR or payback change between new battery versus used battery for a BESS project? So would Alex like to take that? So payback change between new battery and a used battery for a BESS project.
Yeah, that's a good question. So as you can imagine, as with all those questions, the answer is usually quite complicated. And as you can imagine, the way you monetize a battery energy storage system is inherently linked to the revenue of the energy market in which you operate, right? Which means that same technology will have a different project economics, whether you install it in India, in the US, in France, in Germany, in the UK, right? So then you have to assess, and then even within a country, how you are going to install and the specificity of your site as well. Is your point of connection very far out or is it close by, will also have an impact on the project economics. So it's a question that needs to be addressed almost side by side, essentially. Through our business model, we are competitive with First Life, so we approach the problem a bit differently. And obviously, I won't be able to go into the details. That's in the interest of confidentiality. Yeah. But we are competitive. But also, one thing that I would like to address is actually, if you think about battery repurposing, the problem that we're fundamentally solving is actually a bit different than, it's not a storage problem. It's essentially a battery waste problem. So if you think about, if you're a fleet operator, you have electric buses, 50 buses that you need to do a battery swap tomorrow. The problem that you're solving is from the perspective of that battery fleet operator, right? Is what do you do with all those batteries that are coming out of your vehicles? And, option one, you recycle those, which today, is going to cost you something. And option two, you repurpose them. So, battery repurposing is about turning that cost liability to a financial opportunity from the perspective of the vehicle operator. And the battery can be as cheap as they are from China, but the fleet operator, there's no use for him to buy a 20-foot container from China. He cannot plug that vehicle batteries within it, right? So because the problem that we're solving is actually a battery waste problem, then it also fundamentally affects the way you need to look at the business model.
Okay, so I'll quickly move on to the next question. Probably this question I'll direct towards Darshan. Darshan, so Yash has asked, can we use second life batteries in slow moving two-wheelers or e-rickshaw applications?
Technically, probably yes. Practically, it is difficult. Primarily because of the form factor, the voltage levels, etc. So it's not a straight pull out and push in kind of a situation. I mean, theoretically and just from technical specs, possible, but practically it's not viable.
Okay. Okay. So theoretically, yes, but practically it might be very difficult. So yeah, probably one last question. Probably I can direct this question to Professor Jayashree. So Srinivasan has asked, what kind of structural and morphological changes occurs with first life batteries, and can they be prevented to extend the life of that battery?
Okay, so that is an interesting question. Can that be prevented? I don't know. I cannot answer that at this moment. But morphology is, at least at this moment, whatever we have seen with the, let's say we have a lot of black masses. In that black masses, if we see the particles of these are spherical particles, right? So if we see that, many times I have seen when I was in Finland, that also I have seen here also, that it's many times cracks. So that is one of the things. So that is probably one of the like change what I have seen so far. And also that this graphite, all these things contains a bit of binder. On the outer layer, so that also like degrades. So it has to be like couple of parameters together. It has to be this. I would say and the chemistry also, this lithium, as I am mentioning, that ratio of lithium versus other transition metals. So that also changes. This couple of parameters at this moment I can think of, but maybe that has to be looked into further details with, like, let's say a completely deteriorated one. Whatever we typically get is from the black mass only. So maybe before actually it is like mixed with other things, so maybe final one. And if a bit of, at least any of the direct recycling approach is already existing and people are trying to let's say the cathode itself, you don't actually mix it with the graphite anode, and you are actually trying to adjust the chemistry on the cathode through some bit of thermal treatment or some bit of adjustment, addition of bit of lithium carbonate kind of things. So that way you can adjust the chemistry. But yeah, but again, still that also requires bit of dismantling. So if even the design is better to like remove, in fact, that's eliminate that step, that is even better. But yeah, the morphology is, that's what I have seen so far. Like it breaks and cracks on the particle level.
Okay. Thanks, Professor, for sharing it. So basically, it needs a lot of chemistry level R&D, I believe, to answer such important questions. I will take the liberty of taking up one more question, and this question I would direct at Neha. So Himanshu has asked, what's the policy perspective and decision so far from the government side for defining EPR credit mechanism for repurposed batteries? So as an EV OEM, what steps are you seeing because till now we are seeing that EPC in terms of EPR, the movement has been more towards recycling. But what's your take on this moving towards second life and repurposes?
Right. Again, a very relevant question, Anubhav, on this. So, if we see the current framework that we have, it basically tackles or answers the question of EV battery recycling, and it treats EV battery, used EV battery or UL EV battery as a waste, right? And that is where it talks about the sustainable disposal.
Yeah.
But I think there's an opportunity where this framework can be evolved, and we can recognize used EV batteries not just as a scrap, but also as a valuable assets which have multiple life cycles. Right. Now, this needs I would say a very clear definition or a separate category on how do you differentiate between a battery which is end of its first life, and then how can you we saw in the presentation also that for certain SOH, you get, there's still a very good potential for second life. But now, if you see as an industry, when the battery gets to the end of life, basically it is up to the recycler or the repurposing company to evaluate it one by one. And we have so many, I would say, vehicles and battery configurations which are available today. So not all of them follow the same chemistry or the same kind of form factor as well. So here I think again one opportunity is that can that be defined as a category, that how do you differentiate between a battery used for second life and battery for recycling. That is another thing. Third, I think we talked when Palash also discussed on few of the metrics or learnings from the global markets. We can see how a digital battery passport can help in tracking and tracing these batteries, because as the volumes will increase, there will be a need for tracking these batteries. Then how can these be again linked to savings, carbon credits, which can help to build the viability for all stakeholders, be it the recycling partners, repurposing partners, for customers, and also for OEMs, because it is actually in the end providing a larger value, and not only as a scrap. So this is my take on this entire framework right now. But as we are in an evolving stage, I'm sure that these will further be evolved to include all of these points as well, as the country.
Yeah. So, I mean, one important takeaway from your answer is, can there be a proper definition of when a battery becomes a waste versus when it is fit for a second life? Probably that is when EPR would also start differentiating, whether it's an e-waste or whether it goes to a repurposer for EPR credits. So thank you all. Great conversation. And I would once again thank all the panelists for sharing their thoughts on this extremely important subject, which is which is second life of batteries. PD, over to you for the closing remarks.
I'm just still figuring out how to get this blue and green removed from my screen. But yeah. So I think I'll have the closing remarks here. And I think we had a wonderful discussion on somebody talking about EPR should have reuse, should reward reuse, circularity credits, somebody talking about collaborations. We also talked about some experiences from 10 megawatt hour of battery energy that they have created. And great points from Neha and Jayashree also. Overall, yesterday we had an incredible milestone moment where we launched first working group on battery Aadhaar that brought out 40 plus organizations committed to building something truly transformational for India's battery ecosystem. Today, we had a webinar on second life of battery. Probably Battery 60 move in the right direction, supporting India's transition towards circular, sustainable, and indigenous battery ecosystem. A heartfelt thank to UNEP, Jeff, Niti Aayog, and all our partners for their continued collaboration and guidance. My sincere gratitude to all the speakers today and participants actually for putting out those questions and probably getting some great answers. The message today was loud and clear. Second life batteries can actually become one of the strongest enablers for renewable integration, probably the storage access also, and a circular battery ecosystem. Thank you once again for joining this conversation. We had a wonderful time, and we look forward to working together in the future too, as we build India's battery future. Thank you everyone for their time, and have a wonderful evening.
Thank you. Thank you, everybody.
Thank you.
Thanks.
Thank you, colleagues. Have a great evening.
Thank you.